Welcome to the Explainer. You know, in the world of massive data centers, trying to update the firmware on thousands of different devices can be, well, a complete nightmare. Today, we're going to demystify PLDM for firmware update. It's the universal language that's finally bringing some much-needed order to all that chaos. Okay, so let's just jump right into it, right? If you've ever had to manage servers at scale, you know this pain. You've got different tools for every component, different procedures. Sometimes you even have to boot into a specific operating system just to run an update. It is a massive operational headache. So the question is, what if there was a better way? So here's our game plan. First, we'll dig into the problem itself. Then, we'll introduce the standardized solution, PLDM. After that, we'll walk through exactly how it works, step by step. We'll even explore how it handles more complex systems. And finally, we'll wrap up with why all of this really matters. All right, let's set the stage. Before a standard like PLDM came along, updating firmware was just messy. It was inefficient, and frankly, a lot of the time, it just wasn't reliable. And this slide, this really says it all, doesn't it? On the left, you've got the old way, a chaotic mess of vendor-specific tools. Every device was its own little island with its own rules. But on the right, you see the PLDM way. We're talking one standardized protocol. It doesn't care what operating system you're running. The whole process becomes predictable, repeatable, and so much easier to manage.
So what is this hero that brings order to the chaos? Well, PLDM, which stands for Platform-Level Data Model, is basically a universal language for firmware updates. Let's meet the key players in this whole ecosystem.
First up, we have the Update Agent, or UA. Now think of the UA as the head surgeon in this whole operation. It's the orchestrator. It usually lives inside a management controller, like a BMC, and it's the one that directs the entire update process from beginning to end. And if the UA is the surgeon, then this is our patient. It's the firmware device, or FD. This is the actual component we're updating. It could be a network card, a RAID controller, you name it. As long as it speaks PLDM, it can be an FD.
And finally, every good surgeon needs their kit, right? That's the firmware update package. It's a single file that contains two crucial things: the new firmware itself, called component images, and a super detailed header. That header is like the instruction manual. It tells you exactly what the update is, which devices it's for, its version. It's the whole blueprint.
Okay, so we've got our surgeon, our patient, and our sterile kit all ready to go. So how does the operation actually happen? Let's walk through how these pieces come together in this really clean, logical process. You know, the elegance of this is in its simplicity. It's basically a structured conversation. The update agent kicks things off, telling the firmware device it has an update. The FD says, okay, I'm ready, and goes into update mode. The UA then shows it the table of contents. And here's the really important part. The firmware device itself pulls the data chunk by chunk. Once it has everything, it verifies it and applies it. Finally, the UA gives the command to activate the new code.
And that point is so crucial, I want to emphasize it. The firmware device is in control of the transfer. It's a pull model, not a push model. This is incredibly robust because the device never gets overwhelmed. It just asks for the next piece of data when it's good and ready. It's a simple idea, but it makes the whole process so much more stable.
Now, this all works beautifully for devices that are right there on the bus, easy to talk to. But let's be real, modern systems are way more complex. What about things like hard drives that are tucked away behind a RAID controller? Well, the PLDM spec has a really clever solution for that too.
Say hello to the Firmware Device Proxy, or FDP. You can think of this as a regular firmware device that has a superpower. It can act as a translator or an intermediary for other components that are connected behind it, components that might not even speak PLDM themselves.
And the way it works is just beautiful. The update agent talks to the FDP using normal PLDM commands, just like any other update. Then the FDP takes that firmware and handles the tricky business of updating its downstream device, using whatever special protocol that device needs. It means the UA doesn't have to know the messy details. It just works. It's incredibly flexible.
So we've covered the what and the how. Let's zoom out a bit. Why is having a standard like this such a big deal for modern systems? What's the real-world impact here?
Oh, the benefits are huge. Management gets way simpler because you have one protocol to rule them all. Security gets a major boost because verification is built right in. You get true vendor interoperability, which is amazing. The whole system becomes more stable, and this one is a game changer for data centers. It is completely OS agnostic.
You don't have to boot a thing. The big takeaway here is that this isn't just some minor technical detail, it's a fundamental shift toward more robust, secure, and manageable hardware.
And what's really amazing is that it pulls all this off on an incredibly lightweight foundation. The baseline transfer size, that's the smallest chunk of data a device can ask for, is just 32 bytes. That ensures the protocol works flawlessly even on really slow or crowded management networks. You know, PLDM for firmware updates is such a powerful model for taming complexity by creating a standard. It really makes you wonder, as our systems just get more and more intricate, what other chaotic processes out there are just waiting for their own universal language? It's something to think about. Thanks for watching.